Hello everyone and welcome to the video lesson of physics, and in today's video I'll be showing you how you can find or calculate force in any given scenario. So there are like 12 to 13 different cases in which you can be asked a question about calculating force, and we'll be going through them, all of them one by one. So before we start it, let's go to the basics. Let us quickly define force, write down its formulas and units. So in very uh, basic terms, all right, a very primitive definition of force is it is a push or pull. Matter of fact, this is something that we study from our middle school sciences. A push or pull is called force, but if you want to be more precise, then the better way of defining force would be rate of change of momentum. Matter of fact, we'll also be solving the case in which momentum of a system is given and you need to calculate force from there. So there are like different ways in which you can define force. Another way is it is an agency which changes or tries to change velocity of an object. This is another way of defining it, but I think the easiest one is the rate of change of momentum. Matter of fact, in A levels you have to use that definition anyway. So force is measured in newtons. The unit of force would be newtons. We'll always be using newtons as the final unit of force, which is in terms of base unit that corresponds to kilograms meter per second square. Right, kgms minus 2. If I split newton into the basic units, that would correspond to kilogram meter per second squared. Now what are the formulas that we would be using to calculate force? Well, there are different formulas depending on different situations, but the famous ones are F equals ma, force equals mass times acceleration, and force equals delta p over delta t, which is the rate of change of momentum. This is another formula. Other than that, sometimes we'll have to find force from pressure. We use this formula, which we study as a formula of pressure, that pressure equals to force over area. Now from there you can rearrange the expression to make force the subject. Also, sometimes we'll need to calculate force from work done, so we use this formula. Once again, we study this formula, this equation, as the equation of work done. All right, we say W equals F dot T. So from there we can find force as well. Other than that, we'll be needing to use this formula when we have a question about extension and springs and elastic objects. We use F equals kx. I'll explain what does k stand for, what does x stand for. It will be all explained in the examples below. Other than that, we also have a formula that we use with principle of moment. F1 d1 equals F2 d2. This is just a short form of saying that the sum of clockwise moment equals the sum of counterclockwise moment. So these are the basics. All right, these are the standard formulas that are very much important before you have to find force in any given scenario. Now, which formula do we choose from here? It depends on the data. Now, let's proceed to the first case. So here's the case 1. The standard case when mass and acceleration is given. And in that case, we have to use the formula force equals to mass times acceleration. F equals ma. Matter of fact, from force and acceleration, I have already made a video about acceleration, all the cases in which you can be asked a question on acceleration. So force and acceleration, you always get questions like probably 6 to 7 marks, paper 1, paper 2 combined. So in that case, when you're given with the value of mass and acceleration, you have to use the formula F equals ma, right? Which is the formula that we get from Newton's second law of motion. Now, if I read the statement, it says a car of mass 1500 kilograms is towing a trailer of mass 1100 kilograms. All right, so car is not alone, is pulling an object as well, is pulling a trailer as well. The trailer can be any other vehicle or anything else along a level road. The acceleration of the car is 1.3 meter per second square. Right, acceleration is given, and mass of the object is also given. We need to ignore friction and air resistance. What is the driving force on the car? All right, the driving force on the car, we have to use the formula F equals to ma, because we are given with the value of mass, we are given with the value of acceleration. All right, so this formula would be compatible here. Both these values are given. Now, what mass do we use? We have to be a little bit vigilant here, because we have to find the driving force on the car, but the car has to pull, or the car has to tow the trailer as well. So we use the collective mass, right? Because the car is not moving on its own, it has to pull the trailer as well. So we add these two masses. Right, these are the kind of variations that you can get. Sometimes there would be a single mass, you just plug it in the place of m, and that would be all good. So F equals mass of the car itself plus the mass of the trailer. This is our value of m, right? We inserted the value of m. Now we need the value of a, which is 1.30. You simply hit it on the calculator and you'll get your value of force, which in that case would be option D, 3380 newtons. All right, let's move on to the next one. The second case. Now, in the second case is pretty much similar to the first case. The only difference is the acceleration is not given straightforward. Rather, you're given with the velocities, and from those velocities you'll be first needing to find the acceleration, and then eventually you can find the force. So the standard formula that we use here would be the same one, F equals ma. But the thing is, the acceleration would not be given straight away, so we have to use the formula of acceleration, v a equals v minus u over t. We find the value of acceleration, we plug it in the main formula, and then we find the force. So now let's take a look at the data. So you see, you're given with the value of mass, this is your m. It accelerates steadily from 10 meter per second. Now this one might be confusing. It says it accelerates steadily from 10 meter per second to 25 meter per second. These are not the acceleration, these are the speeds, right? Or you can, if you have the idea of units, I mean you should be having it, that meter per second, it is a unit of speed or velocity. In that case it means the same thing. So it is not the acceleration, it is the velocities that is given in the data. So it accelerates from 10 to 25. So starting from 10 means and 25 is your final speed, final velocity. In how many seconds? In 5 seconds. So this is your value of t. All right. So first of all, you can quickly find the acceleration, and then you can plug it in the main formula. So acceleration equals v minus u divided by t. 15 over 5, that would be 3, ms minus 2. Then you use the formula of force, F equals m, which was 1500, times 3, which would be 4500 Newton. So C would be your final answer. Alright, now let's move on to the next one, case 3. Now it is a case in which is slightly different from the first two. Now you have to calculate force from momentum. All right, now momentum is something which has been there in IGCSE and GCSEs, but recently added in O levels from 2023 syllabus. You'll be tested for momentum as well. All right, so in that case the formula that we use is F equals rate of change of momentum, delta P over delta T. All right, now what does that delta P stand for? It stands for the change in momentum, final momentum minus initial momentum. This is the delta P, change in momentum. So what does the question look like from here? Let's take a look at this one. The mass of the hammerhead is 0.15 kilograms. The speed of the hammerhead when it hits the nail is 8 meters per second, and time is also given. So let me just point out the data. This is the value of mass, this is the value of time, this is the value of initial speed. The hammerhead stops after hitting the nail. This is the final speed. Calculate the change in momentum of the hammerhead. So the change in momentum is represented by delta P equals mv minus mu. All right, I've already written the answer. 1.2 Newton second is the answer, because our topic was not to calculate momentum, we have to calculate force from here. But the formula that you use to calculate change in momentum would be mv minus mu. MVU, all the values I have pointed out in the data. So you just insert those values and then you calculate the change in momentum. Whenever we calculate change of something, we don't generally write the negative sign. So even if your change was actually with the negative sign, you don't write down the negative sign with the answer. State the impulse. All right, impulse is the same thing as change in momentum. Matter of fact, every question that starts from state is generally 1 mark question, and in that case you don't need to calculate anything. It implies that something you would have calculated already, or would have been mentioned in the data, or must have been a fact that you just need to write down. So I'm not adding the details of relation between momentum and impulse, because that is not the main topic. Rather, our topic is to calculate the force, right? The average force between the hammer and the nail. Now we write down the formula that I was saying. Force, average force equals change in momentum delta P over delta T. Now let us insert the values. Delta P change in momentum was 1.2 divided by T was given as 0.0015. It was just given in the data. Then you divide these two, and the answer that you get from the calculator is 800 Newton. Alright, so this was the type 3. Alright, in the next type 4, we have to calculate force using the principle of moment. And sometimes they don't directly use the word force, but they ask you to calculate weight. But then you have to notice, or you have to keep in your mind, that weight is nothing but a certain kind of force, right? It is just an example of a force. What kind of force? The force which is exerted by a massive object towards its center. In that case, in our context, we refer it to the planet Earth. So the formula, once again, that you use in that case would be F1 times D1 equals F2 times D2. All right, considering that there are only two forces acting across the pivot. Now let's take a look at the question. So in this one, you can see there are two forces given. The weight of the girl is 550 Newton, you can call it F1, and the weight of her brother is W Newton, you can call it F2. Then you're also given with the distance of the first force from the pivot, and that distance is, you can label as D1, and the distance of her brother from the pivot is given as 1.1, you can label it as D2. Alright, so this is the data, and you need to find the force F2, which they have called as weight. So let us write down the formula once again. F1 into D1 equals F2 into D2, and F2 is something that you need to calculate. And in the next step, you can simply insert the values in that. Instead of F1, we write 550 from here. D1 is 0.86 equals F2, and the D2 we shift on the other side, it would be in the denominator, and that value, if you hit it on the calculator, it would come out to be 430 Newton. Alright, so 430 Newton would be the weight of her brother. So this is how you can find force from, or by using the principle of moment. F1 into D1 equals F2 into D2. A very important one. Sometimes you get a question, 3 marks, 4 mark question from this concept as well. Alright, the next one is calculating force from extension and spring constant. Alright, so sometimes you get a question which you have to solve from a graph. Sometimes there's just a description that is given and you need to calculate force from there. Like if Yeah, first of all, let me write down the formula once again. F equals kx. All right, this is a standard formula that you use. K here stand for spring constant. So spring constant basically tells you how hard or how soft your spring is. The bigger the value of K, the harder the spring is. The smaller the value of K, the softer the spring is. X here stand for extension, and that equals the new length, the total length after the extension minus the original length. Right? But this thing is something that we study separately in the chapter of extension. Right now we're not like getting deep into that stuff. We just have to understand K stand for extension, K stand for spring constant, X stand for extension. Now let's take a look at the first question. A spring constant extend elastically by 10 centimeter with a force of 20 Newton. So the force is producing some extension. So it reads that when the force was 20 Newton, the extension was 10 centimeter. Now it says what force would be needed to extend the spring by 5 centimeter. So now the extension has to be 5 centimeter, but what force would be needed for that? Now from here you can simply cross multiply that and you'll be getting 10x equals 20 into 5 and yeah, you can simply cancel it out to the 20 and 10 Newton. So the answer would be 10 Newton, and that makes sense. I mean, if you just try to make sense of it, a force of 20 newtons produces extension of 10. Now you need extension of only 5 centimeter. You need half the extension. So for that case, you would need half the force. So half of 20 Newton would be 10 Newton. So you can solve it that way as well. Now the next question is the spring extend elastically by 10 centimeter when a force of 2 Newton is applied. What is the value of spring constant? As you see, the formula once again was F equals kx. In this question, you're given with the value of F, you're given with the value of extension. You need to calculate spring constant, right? So out of these three things, any two things would be given and you'll be asked to calculate the third one. It's not necessarily a formula of finding force or finding spring constant. You can find any given thing from the three things provided the two things are given. Now, but one thing that you have to realize is all the answers are with the unit Newton per meter, Newton per meter, Newton per meter. And the extension that they have stated in the question is in centimeter. So you have to convert centimeter into meter. So it would be 0.1 meter. Now you insert the value of F2. K would be there as it is. The value of X would be 0.1. So 2 divided by 0.1 goes to K. We add 1 0 here, 20 over 1 would be 20 Newton per meter. Or just simply hit it on the calculator from there. Don't rely on your mathematical skills a lot if you're not very clear with it. Just hit it on the calculator and get your answer as fast as possible. Alright, the next type number 6 is using force, calculating force from Pascal's law. So the expression for that is, the mathematical expression is F1 over A1 equals to F2 over A2, which is basically that equation means, in simple word, this equation means the pressure on one side equals to the pressure on the other side, and then from the pressure we it would be basically be P1 equals to P2, which is the Pascal's law. Now if you exert pressure on one side, it would be transmitted equally in all directions. So you can just spot this kind of type from the fact that you'll be given with two value of forces and two values of areas. Like this force is given as 80 Newton, you can call it F1. What would be the upward force on the piston L? You can call it F2, which you need to calculate, and 40 centimeters square you can call it A1, and 2 centimeters square you can call it A2. Now let us write down the formula once again, and then we simply plug the values in the formula. F2 over A2, so F1 was 80 divided by 40. F2 needs to be calculated, divided by A2 was 2 centimeter. Right, from here you can solve it for the value of F2, which would be like 42s are 80 and then 2 to the 4. So 4 Newton would be the answer of this one. Alright, the next type is pretty much the extension of the same type, or these two are pretty much the similar. You're given with the pressure and you need to find the force. So in that case, the formula that you use is force equals pressure over area. Force equals pressure times area. Area equals to force over pressure, pressure per unit area. Pressure equals to force acting on a unit area. From there we make F the subject and we rearrange the formula, and force equals to pressure times area. Now let us point out the data. Let us highlight the data from the question itself. The weight of the garden table is 40 Newton. Okay, now this is something that we might need to consider. This is the weight of the table, and the surface area of that table is 2 meter square. So you can call it A. It is raining and the rain produces a pressure of 4 Newton per meter square on the table. So pressure is given. So what the question is, it looks like this. This is your table, all right, and the weight of the table itself, the weight of the table is 40 Newton. Now it is raining. It says it is raining and the rain applies a pressure of 4 Newton on the area of 2 meters squared. So from that pressure and being applied on an area, a force would be produced on the table. Downward force would be there on the table. So what you need to find is the total force that would be exerted by the table on the ground. So the total force would be the sum of weight of the table plus the additional force that is there due to the rain. All right, if there were no rain, then the table would simply exert a force of 40 Newton on the ground, because this is what the weight of the table is. But now we know that it is raining as well, and due to that rain, an additional force would be applied on the ground. So first we find out how much force is being produced due to rain, and the formula for that is this one, like I wrote above. pressure was 4, area was 2, then you take product of it, 8 Newton. So 8 Newton is the extra force that you get from the rain. Now what is the total force? It is the sum of weight and this one, 8 Newton plus 40 Newton, which is 48 Newton. Alright, case number 8. When an object is moving in a circle. In that case, when an object is moving in a circle, the resultant force write it over here. The resultant force is also called as centripetal force, represented by Fc, and that force is directed towards the center of the circle. All right, towards the center of the circle. Which circle? The path, the circular path around which the object is moving. So the resultant force would be directed towards that, towards the center of that circle. Now, I mean, the centripetal force itself is totally different topic, and we study more details in A levels, where you realize that centripetal force itself is not a force like I've written. It is a resultant force, and it is there due to combination of different forces, or there's always a certain force that proves to be the reason of that centripetal force. It might be friction, or it might be any other force. It might be gravitational force between two planets, it can be electrostatic force between two nuclides, or it can be anything. Now if we refer to the question, it says the car moves in a circle at constant speed. What is the direction of resultant force acting on the car? So it would be towards the center of the circle. So this X represents the central point of the circle. So what direction is towards that circle? B. So B is the right answer for this one. Alright, the next case is the case of the terminal velocity, and that is very important one. I mean, every time you get a question about terminal velocity and the force related to terminal velocity. So I've compiled all the possible cases that you can be asked from terminal velocity as well. So here I'll be writing the case, and then they might ask you about the weight, they might ask you about the AR, the air resistance, which would be in Newton, weight would be in Newton, and they might ask you about the resultant force, which would also be in Newton. Right? So what are the two cases? Well, the first case is when the object is moving towards the terminal velocity. Now, right now I'm not discussing what the terminal velocity is. That's a completely different topic. But when the object is approaching the terminal velocity, then there are different cases, there are different things going on with these forces, and when the object has reached the terminal velocity, then there are different things that goes on with these forces. So the first case is when object is reaching the terminal velocity, right? It has not reached the terminal velocity. It might reach the terminal velocity after 2-3 seconds, but it has not reached the terminal velocity yet. All right, TV here does not stand for television, it stands for terminal velocity. And the other case is when the object has reached the terminal velocity. Here I can write for I have enough space here at terminal velocity. So from this thing, you're asked question in two different ways, in two different cases. So first you need to uh, realize what kind of case they're asking the question from. Is it from the case when the object has not reached the terminal velocity, or is it the case when the object has now reached the terminal velocity? All right, so when the object has not reached the terminal velocity and it is approaching the terminal velocity, well, in that case, the weight of the system or the weight of the object is just constant. If it were 5 Newton, it would remain 5 Newton. And the air resistance as you're approaching the terminal velocity increases. Now, every block here, every cell here is an independent question. I mean, they can combine this thing with this thing. They can ask you, when an object is reaching the terminal velocity, air resistance, what happens to the air resistance? Increases, decreases, remains same, or none of these? And the resultant force, it decreases. Basically, the resultant force is the difference of air resistance and difference of weight and air resistance. So if the air resistance is decreasing, then the resultant force would be decreasing. All right, and when the object has reached the terminal velocity, its weight would be just the same, or it doesn't change unless you bring it from, you dramatically change the altitude or height of the object. The air resistance at terminal velocity equals the weight so whatever the weight of the object was, the air resistance keeps increasing, and exactly at terminal velocity it equals to the weight of the object, and that is the maximum value of air resistance that can act on the object during free fall. And resultant force in that case would be 0, because the resultant force is the difference of weight and air resistance, and if you subtract two same quantities with same magnitude, if the weight was, let's say, 5 Newton and the air resistance at terminal velocity would also be 5 Newton, and the resultant force would be 5 minus 5. Why we subtract them? Because weight is downward and the air resistance acts opposite to the weight, which is upward in the free fall. The air resistance is upward. And sometimes they ask you about a question about acceleration as well. So whatever thing goes with the resultant force, same happens with the acceleration. So when the object is reaching the terminal velocity, the acceleration decreases, and when the object is at terminal velocity, it is not accelerating. Acceleration would be 0 because resultant force is 0. Alright, then we have a question that is related to the same concepts. Or matter of fact, if you memorize this table, if you understand this table, you'll be able to answer any question related to resultant force, terminal velocity, air resistance. Now here we have the next question. You're given with the force P, which is pointing upward, the force Q is pointing downward. So it says, question reads, a coin falls through the air from the rest, eventually reaches a constant speed. So that case is, you realize they have mentioned that it reaches a constant speed. So the case is when the object has reached the terminal velocity, right? This is the first thing that you need to point out from there that the object has reached the terminal velocity. So you use those facts and those pointers where the object has reached the terminal velocity. The second one, two forces P and Q act on the coin. What will happen to the force P? P force upward would be the air resistance. Q force downward would be the weight of the object. So what happens to P and what happens to the resultant force on the coin before it reaches the constant speed? Okay, all right. So the question that they are asking is, what happens to the force P and what happens to the force Q? No, sorry, what happens to the force P and what happens to the resultant force before it reaches the terminal velocity? So here they are saying you have to answer before it reaches the terminal velocity. Although the object has reached the terminal velocity, but the question or the about the forces you have to answer before it reaches terminal velocity. Constant speed here means terminal velocity when the object is having free fall. So force P is the air resistance. So you go up there, you say before the object reaches the terminal velocity, what happens to the air resistance? It increases. So can't be this one, can't be this one. Force P increases, and what happens to the resultant force? Resultant force decreases. So it has to be increases from here, decreases from here. It has to be the option C. So C is the right answer for this one. Alright, so the next case number 10, is to find the resultant force of parallel forces. Parallel forces means the force that are along the same axis. Alright, the forces that are along the same line. These two directions never intersect. They can be in the same direction, they can be in opposite direction. So in that case, the rule is, if the forces are in same direction, you simply add the forces. For them being in the same direction, you add the forces, and if the forces are in the opposite direction, you subtract the forces. Only these two are the rules that you need to apply when the forces are parallel to each other. And when we say the word parallel, it means they can be anti-parallel as well. So it's just the special kind of parallel forces. So now we have a sample question, and in this one you need to find out which object has the largest resultant force. Okay, so let's check it out. The object A has a resultant force of 10 Newton towards right. How do we know? Because these two forces would be added up, it makes 20 Newton to the left, and then 20 Newton to the left and 30 Newton to the right. Then you subtract them, the resultant force be towards the bigger force, which is 10 Newton. From here we get a resultant of 10. From here, from B we get a resultant of 10. Towards right, from C we get a resultant of 20 Newton towards left, because that add up to make 10 Newton. Then 10 Newton subtracted from 30 Newton would be 20 Newton to the left, and in D we get a resultant of 15 Newton. So the largest resultant that we get from is the KC. So C is the right answer for this one. Alright everyone, so the next type is resultant force when the forces are not parallel. So when the forces are not parallel, now from the latest syllabus, according to all levels, and in the latest syllabus, if the forces are not parallel, then they would be perpendicular. But in other cases, if the forces are not parallel, they may not be perpendicular as well. Okay, they may be in different directions like this one as well. So if the forces are perpendicular to each other, here I'm writing, if the forces are the two forces for which you need to find the resultant, all right, and if the forces are perpendicular to each other, then what you can do is you can find the resultant force by using Pythagoras theorem. You can find the magnitude of resultant force by using Pythagoras theorem. Might be incorrect with the spell of it, it's okay. You can find the magnitude of resultant force by using Pythagoras theorem, and you can find the direction by using the formula theta equals tan inverse of perpendicular, I can call it like the forces along the y-axis divided by base. And if the forces are not perpendicular, then you have to use the scale diagram. Matter of fact, the scale diagram can be used with any case. If the forces are parallel, perpendicular in any direction, you can use the method of scale diagram. Alright, so let's move on to the question. So this is a sample question that you have. What you see now, first of all, you need to, in the part A says draw a scale drawing, right? You have to use the scale drawing method, and you need to find the resultant force. Now what is the relation between the two forces that are given? 12 Newton, kilonewton, 36 kilonewton. These two forces are perpendicular to each other, and we need to use scale drawing to determine the resultant force. We need to find the size of the resultant force, then we need to find the angle of the resultant force. Now for the scale drawing, first of all you have to draw a proper scale, an appropriate scale, right, that would be suitable for the values of force that are given in the question. So I have to deal with the force of 12 Newton, 12 kilonewton and 36 kilonewton. Now when I have to represent these two forces on the paper, I have to draw a line. There has to be a certain length of that line. Now we have to draw a scale by which we can say how long, how many centimeters the line of this force would be, and how many centimeters the line of this force would be. So for that, in order to have a uniformity, you need to make a scale. What I say is I'll be drawing a line of 1 centimeter for every 6 kilonewton force. This is my scale. All right, what I'm saying is if length of the line would be 1 centimeter if the force is 6 kilonewton. Now that means according to that scale, for the first force I need to draw a line 2 centimeter, because it is 12 kilonewton for 6 kilonewton. I need to draw 1 centimeter. For 12 kilonewton, I need to draw 2 centimeter. And for the other force, 36, I need to draw a line 6 centimeter. Alright, so you do it that way. The first line over here has to be 2 centimeter. Alright, and it has to be done with a ruler. Right now I'm not using ruler, I'm just assuming that this line is 2 centimeter, but I'm writing down the values because you then need to use a ruler. And then at the end of this force, you draw a line of 6 centimeter. It should be like 3 times bigger than that. So I assume that this line is 6 centimeter. Make sure you draw with a ruler. So this one was my starting point, and this one was my ending point. And the final step is that you draw a line from the starting point to the end point. Join the starting point to the end point. Okay, just a plain line here. Yeah, you join the starting point to the end point. So this one is your resultant force. Now the next step is measure the length of this line with the help of the ruler. So you use ruler to measure length of this line. Alright, the alternate method is, you see this is a right angle triangle, and the alternate method is you can use the Pythagoras theorem, and that would give you the length of this red line, which in that triangle is a hypotenuse. So you can simply say the resultant for the red line is your hypotenuse, and that equals the perpendicular square 36 plus base square would be 4, and that would be 40 under root, and that would be, let me hit it on the calculator, it would be 6 point something, 40 square root 6.32, so 6.32 centimeter. So now let's say I measured this line with the scale with the ruler, and the length of this line is 6.32 centimeter. Now the next thing is, if the length of this line is 6.32 centimeter, how many kilonewtons does that correspond to? Now you have to go back to the scale. I said if I have a line of 1 centimeter, it would be 6 kilonewton. If I have a line of 2 centimeter, it would be 12 kilonewton. If I have a line of 3 centimeter, it would be 11 kilonewton. Now if I have a line of 6.32 centimeter, then that would be 6.32 centimeter, then that would be times 6 kilonewton, right? Then you can hit it on the calculator, times 6, so 37.9 kilonewton, or in 2SF you can write as 38 kilonewton. Alright, 38 kilonewton. This is the drawing scale method. Now you need to find the direction angle as well. So you need to find the angle of this resultant force with the horizontal, the angle of this resultant force with the horizontal. So what you can do is simply place your protractor here and find this angle. All right, just place the protractor here like this, and you'll be finding the value of angle from there. And if you were using the Pythagoras Theorem method, for that you can consider this is a right angle triangle, and then you can use tan theta equals perpendicular, which is 6, divided by base, which is 2. Alright, and then you can find theta from here. Theta would be tan inverse of 3, and if you hit it on the calculator, tan inverse of 3, that comes out to be, just hit it, yeah, 71 in 2SF. That comes out to be 71 degrees, and that makes sense. Take a look at that. The angle is slightly less than 90. It appears to be more than 45. Right, 45 would be like in the middle of 0 and 90, so it appears to be 70. Right, so that is generally a 3 to 4 mark question, and probably the most difficult question that you can get from finding the forces, finding the resultant force. But if you practice it, it's not that much difficult, and you can easily score 3 to 4 marks. Alright everyone, so the next case is when they ask you the question about frictional force. Right, so for this one, for the frictional force, it is quite easy. There's not much variation in it, and for frictional force, the general rule of thumb is that it acts opposite to the applied force. So if you apply a force forward, if the motion is forward, the friction would be acting backward. So that is the general concept. And one more thing about frictional force, I can write over here. When object is moving at constant speed, in a straight line, so I better be writing at a constant velocity. When an object is moving at a constant velocity, then the frictional force equals to the applied force, and that means the two forces are equal and opposite, so the resultant force would be 0. Just keep in mind, if in a question they ask the object is moving at a constant speed, so that would mean the forward force and the backward force acting on the object would be equal. The forces acting on the object would be balanced. The object is not accelerating. The resultant force is 0. Alright, so the man is pushing the box forward, and what we need to find is the direction. In which direction do the forces act on the man? Okay, force on man's hand. So man is pushing the box forward, and the force acting on the man's hand would be backward. This is basically according to Newton's third law, right? It is application of Newton's third law. And force on man's feet. So man is pushing the ground, the man is pushing the floor backward, and the force acting on the man's feet would be forward. So force on man's hand would be towards the left. So this is inaccurate, this inaccurate, and force acting on the man's feet would be forward. B is the right answer. So about frictional force, this is one of the most important thing, because many of the students, they think if an object is moving, then the applied force is moving at a constant speed, because they assume that the object is moving. So the force, frictional force, has to be less than the applied force, or the applied force has to be more than the frictional force, because the object is moving. No, it's not like that. If the object is moving with a constant velocity, then these two forces, frictional force and the applied force, would be equal to each other. The reason being is because the object is not accelerating, and it would the practical example would be if you're sitting in a vehicle on a very plain road on a motorway, and you're traveling at a very constant speed. You don't change the speed, you don't increase or decrease the speed. It appears that you're not even moving, right? If the road is very plain, there's no ups and downs, no bumps on the road, and you maintain the speed constant, it would appear that you're not even moving, because the resultant force is not even there. The resultant force is zero, and you're not accelerating. All right, so let's move on to the next one, which is pretty much the same as the previous one, force according to the Newton's third law. So in this one, you need to consider the most important thing is force that you're applying, I could call it action, and the force that is there due to that action, we call it reaction. Those two forces, action and reaction, they are in terms of magnitude, they are equal, and opposite in direction. In terms of direction, they would be opposite. So this question, if you take a look at the question, it says the propeller on the boat pushes the water backward with a force of 2000 Newton. Okay, propeller on the boat pushes the water. So propeller is applying force of 2000 Newton on the water. Now, first of all, read the question. The question says, according to Newton's third law, what is the forward force on the propeller due to water? So what they're saying is the propeller was applying a force of 2000 Newton. How much force the water would apply on the propeller according to Newton's third law? So we know according to Newton's third law, action and reaction are equal. So the same force would be applied on the propeller due to water. So it has to be 2000 Newton. Now they have given the additional force, resistive force of 1800 Newton, but this has nothing to do with this question itself, because the question is strictly about, according to Newton's third law, what is the forward force on the propeller due to water? So which is the reversal or the reactional force of this one. So this one was your action, and this is the reaction. All right, let's move on to the next one, and in this case you'll be asked to find the force from work done. All right, so the formula that we use in that case is force equals work done divided by the distance covered in the direction of force. All right, so a cyclist is riding along a flat road. The cyclist, who is a physicist, knows that his speed that speed she has 3.2 kilojoules of kinetic energy. So that energy, in that case, it is the energy that will be used in order to do the work done. When she applies her brakes, she stops in just 6.4 meters. She covers a distance of 6.4. What is the average braking force? So energy and work done in that case means the same thing, because they are measured in the same unit first of all, and the amount of energy that you have would define how much work you're able to do, right? So if uh, you, uh, energy of 100 joules is transferred to a body, that means you're doing a work done, you're doing a work of 100 joules to that body. So what I can say is the work is given as 3.2 kilojoules, but first of all you can convert kilojoules into the standard unit joules, be 3200. So this is your value of W, and the value of D is 6.4, and you need to find the work done. So that would be F equals 3200 divided by 6.4, and when you hit it on the calculator you get 500, and the unit of force would be Newton. So these are all the cases in which you can be asked a question about force, and you always get a question in which you have to find force in acceleration. I've already made a video of acceleration. If you have confusion in how to find acceleration in any given scenario, you watch that video and you'll be able to calculate acceleration in any possible scenario. So the extension of this video would be finding force in the cases of electromagnetism in static electricity. This was all about the mechanics. Okay, so I'll be making another video in which I'll show you how you can find magnetic force, force in electromagnetic cases, forces which is there in the DC motor and stuff. But for this video, that's it for today. See you in my next video lesson. Take good care. Allah Hafiz.